Okay, so it's price theory, graduate level price theory. We have 4 prices. I just wanted to point out we've introduced 4 prices now. One's the private marginal cost. In the positive externality case, that was the highest of all the prices. 1. There's the average price, and that's going to be less than 1. If there's any cooperation whatsoever, it'd be less than 1 with the positive externality. There's the marginal price, which I've called M. That's below that. And then there's finally the social marginal cost without the cooperation. That's the 1 minus delta. So we have the 4 prices, and we can order them in this area. It's one thing we do a lot in price theory, keep track of the prices. Bob already talked a lot about having 2 prices, kind of a supply price and a demand price, before tax price versus an after tax price. Remember this morning when he was going through, oh, what if you started your analysis from what the seller got versus what the buyer got? That's 2 different prices he was talking about. Here we have 4. And you don't want to get them confused unless you want to be embarrassed as a price theorist. They're very distinct things, and they can move in different directions. Yeah.
So the price that we observed in the real world, is that the average price?
Well, I mean, I want to look at what the transactions are. I'm going to dig into it. One way a group might organize itself with a positive externality. Oh, here's the picture. Each purple box is a price, a label for a price. So take a volume discount. So there's going to be some R, and Murphy's going to talk about this in more a buyer-seller context tomorrow. But suppose we're going to give people a discount. It depends on how much they buy. So Q is how much the individual buys, and R is the discount percent or share discount that they get. And R prime of Q is increasing. The more you buy, the bigger the discount. If you buy a little bit extra, you get 10% discount. You buy more than that, you maybe get 20%, etc. So what's the net price that they pay? And I'm going to change the 1 to an L here just to keep track of it, or otherwise you have too many 1s going around doing the same thing. So L is that top price that I've talked about. And say, okay, well, what's the effect on expenditure, the consumer's expenditure under this volume discount scheme of raising his quantity? I would just take a derivative with respect to quantity, but we have a couple terms. One is the usual term. Well, holding constant my discount, it's just my net price. I have to pay the net price for an additional unit quantity. But then I also save because I get a bigger rebate on all my other quantities that I was already buying. And that's what I've called the marginal price. So to get to your question, Peter, sometimes we have information about the net price. Sometimes we have information about the marginal price. Sometimes we have information about what the seller gets, what the buyer gets, what the buyer pays. You need to keep track of that stuff because, except in the simplest cases, we have more than one price. And the theory says very clearly, and I think we see it in a lot of applications, the prices are going to be ordered this way. This is what I called 1 before, the top price. Then there's going to be the net price. And then below that's going to be the marginal price. Okay, let's look at a little bit at I think we can do this. Look at public goods. So public good is just a special case of an externality, and it's symmetric. Everyone receives the same externality. One way to look at it analytically is there's a good. Everybody contributes, each individual contributes some amount X to the total good. And then each individual's utility depends on Q as before. So there's some U of Q. Each individual benefits from Q, but they contribute to the total. And here I'm going to take it symmetric. People contribute the same. It's N times the average contribution X bar. So the private marginal cost, which I've called 1 before, is still 1. But the social marginal cost is 1 over N. For each individual to enjoy more of this public good, we only need to get each individual to contribute 1 over N to add 1 to it. So this becomes just a special case of the picture I showed before. I called this 1 minus delta before. Now we have a more precise formula, 1 over N. Just count up the people. So that's a powerful quantitative result. Now we kind of know the gap between these prices. There's one is 1, and the other differs by a factor of N. Sometimes the way this is put, and it's equivalent, is to say, well, the efficient amount of the public good is where the sum of the willingness to pay equals the cost. I've just divided each side by N to say it, to put it into my picture. So you're going to have easily be an order of magnitude difference between these two prices, group of 10. Very strong incentive for trade, even in the group of 10. Again, they might not get all the way there, the cost of cooperating, but big incentives to do something. Okay, we did this already. I'm going to skip these. I want to go to